Hi everyone and welcome back to Matter for Thought. For this episode, I have the honor to host here, again, a good friend and amazing person, MCToon. You can have it from here.
The previous episode ended with the fact that in this episode, we will do an exercise that should cover most of what we learned. So let's start describing the scene. On the left side, there is a sloped surface at an angle of 45 degrees to the bottom right, starting at floor level, and at the end of a ramp at an angle of 37 degrees. A ball of mass M is located 10 meters from the bottom of the slope, and at a certain moment it is released and begins to accelerate until it reaches the edge and then is thrown into the air and continues the motion under the influence of gravity alone. 1. What will be the distance from the end of the ramp at the moment of hitting the floor? 2. What will be its maximum height in the air? You're invited to stop here and try for a moment alone, then we'll solve it together. Come on, get to work. Let's start by finding the speed of the ball at the bottom of the slope. This is a movement under the influence of gravity and normal. The force of gravity is mg, and the normal is mg times the sine of the angle. The sine of 45 degrees is 1 divided by the square root of 2, so the size of the normal is mg over root 2. We will break down the normal into its components. The x component is multiplied by the sine, and the y component is multiplied by the cosine. The angle is still 45 degrees, so again we divide by root 2 and get that the x component is 1/2 mg to the positive side, and the y component is 1/2 mg upwards. And when summing it with mg downward, we get that the net force in the x-axis is negative 0.5 mg, and therefore the acceleration is negative 0.5 g. We will add x and y together and get that the magnitude of the acceleration in the direction of the slope is g times root of 1/2 squared plus 1/2 squared, which is g over root 2. Great, there is acceleration. Now we will find the velocity. The velocity formula is v of t equals v0 plus a times t. To be able to use it, we first need to find the time it takes for the ball to reach the bottom before we can continue. The formula of position depending on time is r of t equals r0 plus v0 times t plus 0.5 a times t squared. The x-axis can be ignored for now because we only want to see when it reaches the bottom, meaning only what happens on the y-axis. Final height, 0. Initial height, 10 over root 2. Initial velocity, 0. Acceleration, negative 0.5 m times g. 10 divided by root 2 plus 0 minus 0.5 mg times t squared equals 0. We multiply, divide, and rearrange to get t squared equals 2.886, and therefore t equals 1.699. We will put the time we got back into the velocity equation and get that the velocity vector is 8.324 negative 8.324. We add up these two velocities according to the Pythagorean theorem, and we get the magnitude of the velocity is 11.77 meters per second. Great. We finished the first part. Now we have a flight through the air under the influence of gravity alone. The slope is at an angle of 37 degrees, so we will split the velocity into the x-axis and the y-axis accordingly. V of x equals 11.77 times 4/5, that is 9.42. V of y equals 11.77 times 3/5, that is 7.06. Now we calculate how long it will take the ball to reach the ground. R of t equals r0 plus v0 times t plus 0.5 a times t squared. R of 0 equals 0. V of 0 equals 7.06 meters per second. And the acceleration is the acceleration due to gravity, 9.8 meters per second squared. We put everything into the equation and we get t of 1 equals 0. That makes sense. We get the moment the ball leaves the ramp. This is the uninteresting result. We will divide by t, rearrange again, and we get t of 2 equals 1.44 seconds. Now we can answer question 1. We will multiply the time we got by the speed in the x-axis, and we get 13.57 meters. To answer question 2, we need to understand when exactly the height is maximum. Maximum height means that from the moment onward, the height is decreasing. That is, the speed in the y-axis changes its direction. So we're looking for the moment when the velocity is exactly 0. We will insert the initial velocity and the acceleration into the velocity equation as a function of time, and we'll see when it equals 0. V of t equals v0 plus a times t. V of 0 equals 7.06. A equals negative 9.8. Desired speed is 0. 7.06 minus 9.8 times t equals 0. We rearrange, divide, and get t equals 0.72 seconds. We will place this time in the position equation on the y-axis and get r of 0.72 equals 0 plus 7.06 times 0.72 minus 4.9 times 0.72 squared. Solving that is basic arithmetic, and the result is 2.54 meters. I hope you saw how simple it is when you do everything in an orderly manner. In the next episode, we will learn about a new physical unit that is obtained when velocity is multiplied by mass.
MCToon, thank you very much. You are all welcome to pay his channel a visit. A link is in the description. Before I wrap things up, I want to thank my patrons. If you like the content, like, subscribe, and share it. And if you really like it, a link to my Patreon is in the description. I was, as always, rndthinker, and I'll see you in the next video.